Hello everyone. In this video lecture, we are going to discuss about operators and how to manage the input outputs in C language. You have different types of operators like arithmetic operators, logical operators, bitwise operators, assignment operators, relational operators, increment and decrement operators, conditional operator, and miscellaneous operators. The increment and decrement operators, of course, come under the arithmetic group. So let's see one by one. Arithmetic operators. So in this group we have addition, subtraction, multiplication, division operators. These four are commonly used operators, and this is something new, modulus operator, which is also called as the remainder operator, which will provide us the remainder of the division operation. Then plus plus operator, this is increment operator, which will increment the value of value by 1. Decrement operator will decrement the value by. Let's see some of the examples. Let's assume A is equal to 5 and B is equal to 2. We have used different operators like plus, minus, star, divide, and we can see the corresponding output. A plus B, 5 plus 2, 7. A minus B, 5 minus 2, 3, like this. And coming to the mod operator, when A is equal to 5 and B is equal to 2, you see here C is equal to A mod B, that is 5 mod 2. In the division of 5 by 2, the remainder is 1. Quotient is 2, remainder is 1. And here for this expression, we are getting the answer as 1 because this mod operator provides the remainder. So 5 by 2, in the operation of 5 by 2, remainder is 1. Similarly, coming to the next example, A is equal to 5, B is equal to 3, that is 5 mod 3. So here quotient is 1, remainder is 2, that is why answer is 2. One more example, A is equal to 3, B is equal to 5, 3 mod 5. Here the remainder is 3 because 3 divided by 5 means quotient is 0, remainder is 3. So the mod operator provides the remainder 3 as the output. Okay. And here all these operators up to this from plus to this one, these are binary operators because here two operands are involved in all these things. That is why which are called as the binary operators. Two operands are two data. C A plus B. So A is one operand, B is another operand. Two operands are two data. So two operands are involved means that is called as the binary operator. The last two things, increment and decrement operators, are called as a unary operator because here only one operand is involved. One operand or one data. So look at the example, plus plus A. So here we have assumed A is equal to 5. So plus plus A will give us 6 because this operator is the increment operator. This increments the value of A by 1. So 5 is incremented by 1, so 6. A plus plus 6. Minus minus A, 4. A minus minus 4 because this operator is a decrement operator, decrements the value of A. It is 5 by 1, so which is 4. So here in all these operations, only one operand or one data is involved, so it is called as the, so these two operators are called as the unary operators. Okay, here actually we have two types of increment and decrement operations, that is post increment, pre increment. So see the examples. B is equal to A plus plus. So this is called as the post increment. That means the value of A will be first assigned to the left hand side variable, then it will increment the value of A by 1. That is, it will post the value of A first and increment the value of A by 1. Okay, so the increment operation is done after the assignment. That is why it is called as the post increment. Okay, so after this is executed, what will happen? Value of B is 5 because A is first assigned. After the assignment, the increment operation is performed. Okay, so B is equal to 5, A is equal to 6. Hope you understood. Post increment. If you post the value of A first and then K increment, or we can say the increment operation is done post the assignment operation. Okay, anyway you can understand. In pre-increment, here you see B is equal to plus plus A. So pre-increment, as the name implies, increment operation is performed prior to the assignment operation. So already A is assumed to be 5. So because of this increment operator, 5 becomes 6. Okay. Then 6 will be assigned to the B. So now for this operation, both B and A are 6. Same thing happens in the post decrement, pre decrement. You see here, now you can say the answer. B is equal to A minus minus. Okay, so A is first posted or assigned to B variable. That is why 5 is assigned to the variable B first. Then the decrement operation is done after the assignment operation. So A becomes 4. Pre-decrement. So prior to assignment, the decrement operation is performed. So minus minus A becomes B is equal to 4 and A is equal to 4. Minus minus A means minus minus 5. So 5 becomes 4. 4 will be assigned to B and B. Okay. Logical operators in C. Here we have three different types of logical operators: AND, OR, and NOT. These operators are used to combine more than one conditions. When we take decision, okay, when we have one more conditions, we can make use of these operators. So let's look at some of the examples. Assume A is equal to 1, B is equal to 2, C is equal to 3. Here we have two conditions. A less than B is one condition and B less than C is another condition. So the logical AND operation means when both the conditions are true, the overall condition is true. Here you see for this assumed values, A less than B first condition which is satisfied. B less than C is 2 less than 3 is also satisfied. So two conditions are satisfied. So that the overall condition provides true. Whereas the logical OR means, as the name implies, when either one of the conditions is satisfied, the output is true. Here for this example, A less than B is satisfied because 1 less than 2. Then C less than B, that is 3 less than 2. This is not satisfied. The condition 1 is satisfied, condition 2 is not satisfied. But what is the nature of this operation? Logical OR operation. When either one of these two conditions is satisfied, the output is true. Since the condition 1 is satisfied, output is true. Then coming to the NOT operation, logical NOT. Okay, so it will negate the condition. Here you see exclamatory symbol followed by a condition A less than B. A less than B is 1 less than 2. Satisfied. But we use the logical NOT operation. So this condition is true. Okay, NOT of true is false. That is why it is false. Okay, suppose if this condition fails, okay, this is false, the NOT of false will become true. But for this example, this condition is satisfied, so true, NOT of true, false. Last example, A less than B and B less than C. The overall condition is negated. Okay. So AND operation we know, and both the conditions are to be satisfied to get it true. A less than B, that is 1 less than 2 is satisfied. Second condition, B less than C, 2 less than C, that is 2 less than 3 is also satisfied. Both the conditions are satisfied. So true. The logical and the two conditions are satisfied. So true. Not of true. So similarly, we can go for any number of conditions. 2 or 3 or up to n we can go for, right? And coming to the bitwise operators. As the name implies, these operators will perform the operation bitwise. For the given value, it will take the binary equivalent and it will perform the operation bit by bit. Okay, and here is the truth table for binary AND, binary OR, binary XOR. And this is binary ones complement. Ones complement is very easy. That is, if the input is 0, output is 1. Input is 1, output is 0. Okay, so for these three things, we have a truth table here. Two variables are there, P and Q. Binary AND operation. So as we know, AND operation will provide the output true only when all the inputs are true. Okay, so here we have two variables P and Q. So when we have two variables, four conditions are there, four possibilities are there, 0 0 0 1 1 0 1 1. So AND operator will provide the output 1 only when these two inputs are 1. So for 1 case only output is 1, for the other cases output is 0. But whereas OR, as the name implies, when either one of the input is 1, output is 1. So here the first condition 0 0. For this case alone output is 0. For the other cases any one of the input is 1. Any one or both are 1, the output is 1. Right. Then exclusive OR. Exclusive OR, the function is actually P Q bar plus P bar Q. This is the Boolean expression for exclusive OR. But to simply understand the function of exclusive OR, you can have a thumb rule like this. When both the inputs are same, output is 0. That is, when the inputs 0 0 and for 1 1. For 0 0 and 1 1, output is 0. That is, for similar inputs, output is 0. For dissimilar inputs, output is 1. So keeping this in mind, we can work out some other examples. So let us assume A is equal to 21 and B is equal to 64. So as we know, bitwise operators will perform the operation bitwise. Okay. So it will first have the binary form of the given number. For 21, this is the binary form. 64, this is the binary form. Okay, A and B. So now it will perform binary AND operation bitwise. So you see here, data 1, data 2. 1.0, 0. 0.0, 0. 1.0, 0. That is, when both the inputs are 1, the output is 1. Otherwise 0. Here actually in our example, both ones are not available. So all the locations are 0. Alright. So the output is 0. Then A or B. A or B. When any one of the inputs is 1, output is 1. So here one is there, 1 plus 0, 0 plus 0, 0. When both are 0 only, output is 0. Otherwise, the output is 1. So this is the output and equivalent value is 84. Then A exclusive, you know that when the inputs are dissimilar, output is 1. When the inputs are similar, output is 0. And binary negation or ones complement. When the input is 0, output is 1. When the input is 1, output is 0. Just complement of each bit. We get this one and the answer is quicker. And coming to the shift left and the shift right operators. Okay. So this is binary left shift operator and binary right shift operator. That means the binary left shift operator will shift the contents of the input left by one location. You see here, all these bits are shifted left by one location. So what will happen? This 0 will come here, this 0 will come to this location, 1 will come to this location, so that ultimately the leftmost bit will be dropped. Okay, because all the bits are shifted left by one bit. So what will happen? this will become 0 will be dropped, this 0 will be dropped, so that the remaining values are 0, 0, 1, 0, 1, 0, 1, and finally we have to add 0. Finally it will add 0. Suppose if we give 2 here, a less than 2 means the content of a will be shifted left by 2 times. So in that case what will happen? The leftmost 2 digits will be dropped out. So it will start from 0, 1, 0, 1, 0, 1, and it will append 2 zeros. That is going to be the answer. Okay, similarly for any number of shift right, answer is 4, 2. Shift right, it will shift the content of A right by 1 bit if it is 1 here. If it is 2, it will shift the content of A right by 2 times. The same thing will happen here. For this example, A greater than 1, right? So this one will be dropped. This one will be dropped, and these 7 bits will be shifted right. And in the leftmost location, it will add 0, right? So likewise, you can take some more examples and try yourself to understand better. Then coming to the relational operators, these operators are used to compare two operands to take decision, right? So double equal to means check for equality, because we know that in C language a single equal to is used for assignment, that we'll see later. Double equal to is used to check for equality, right? Then exclamatory followed by equal to is not equal to, then greater than, less than, greater than, equal to, less than or equal to. These are all the relational operators. See the example say, let us assume A is equal to 10, B is equal to 20. For this case, if we go for this condition, A equal to B, that is 10 is equal to B. This is not true. Okay. When both the values are same, this will be true. Right. Now for this example, this is false. That is, it is not true. Then A is not is equal to B. That is so. So it is true. A is greater than B. False. That is not true. A less than B. True. A is greater or equal to B. Not true. Less than or equal to B. True. Right? Then assignment operators. So the assignment operator is equal to. Equal to symbol is the assignment operator. This is used to assign the value from right hand side to left hand side. Example is C is equal to A plus B. What will happen? It will perform or it will evaluate A plus B, and this value will be assigned to the variable C. Right. And also we can combine the arithmetic operators and binary bitwise operators together with the assignment operator, as you can see here. That is, we can affix any arithmetic operators or bitwise operators in front of the equal to symbol. These are called as the shorthand operators. Shorthand operators. Look at the example. C plus is equal to A. C plus is equal to A. That means C is equal to C plus A. So it's a C is equal to C plus A. Normally we will be writing. This can be written as C plus is equal to A. This is a shorthand operator. Similarly, we can use shorthand operators like this. You can see the example for those things. Right. That is, the operator should be affixed in front of the equal to symbol. So instead of repeating the variable twice, instead of repeating the variable once more, we can go for the shorthand operator, as you can see here. See here, C divide is equal to A means what? C is equal to C division. The same thing, same phenomena applies for all other operators. Then conditional operator, which is also called as a ternary operator. So far we have seen unary operator, binary operator. Unary operator involves single operand, binary operator involves two operands. Here it is ternary operator. So ultimately we can understand that this involves three operands. Okay. So the Symbol is question mark followed by colon. The syntax of this conditional operator is condition question mark expression if true colon expression if false. So you can see here three operands are there 1, 2, 3. So 3 means that is ternary operator, right? So let us look at the example. Example 1, a is equal to 5, b is equal to 6. You see here c is equal to a less than b question mark 1 colon 0. So the first one is the condition. If the condition is satisfied, what will happen? This conditional operator will assign the operand 2, that is expression if true. Here it may be a single value or it may be an expression. Okay, here in this example 1 is given. So since the condition is satisfied here, that is 5 less than 6, this 1 will be assigned to the variable c. That's what we have seen here. Example 2, a is 5, b is 6. Okay, the condition is satisfied again. You see here instead of 1 I have given a plus b, or any other expression can also be given. So this will evaluate this expression and this will be assigned to the left hand side variable. So a plus b, a plus 6, 11 is assigned to c. Example 3, a 6, b 5. Condition is not satisfied here. So that what will happen? It will assign the expression or operand 3 when the condition is false. So here the condition is false, so that it will assign the third operand or the expression if false, that is a minus b in this example. A is 5, b is 6. So sorry, a is 6, b is 5. So the answer is 1. So a minus b will be assigned to c. So 6 minus 5, 1 will be assigned to c. Got it? Fine. Now the miscellaneous operators. We have brackets, square bracket, parenthesis, dot, hyphen followed by greater than symbol, and star size of type. So this brackets operator is a function call operator. We used to call the function. Brackets is used for array subscript. Parenthesis is used to group the set of statements. This can be used in control structures or in function body. Dot operator and this one, all these things are used in the pointers. Okay, pointers. Then size of operator will provide us the number of bytes of the data type. For example, size of int will provide 2 because it occupies 2 bytes. Size of float will give us 4, that is it will occupy 4 bytes. Size of double, the double data type will occupy 8 bytes, it will provide 8, like that. Then the type operator, this is the cast operator. So this will convert the data type from one to another. If you want to convert an integer to floating point or floating point to integer or whatever, we can go for this. Okay. For example, I have the floating point value, say 2.5. Okay, I want to convert that into integer. So what I can do, I can use the statement within brackets int followed by 2.5. So what will happen? 2.5 is the floating point value, but the type I have given is int. So the floating point value 2.5 will be converted into integer type. So it will provide only 2. So for this we can use this type operator or cast operator. Then the hierarchy of operators are operator precedence and its associativity. So when an expression is being evaluated, okay, in what hierarchy or in what precedence the operators are taken into account is given here in this order. In this order, the hierarchy will be followed, and this is the associativity. So to understand this, let us see some example. A is equal to 1, B is equal to 2, and C is equal to 3. Okay, D is equal to A plus B into C. Here, You see, here we have two operators plus and star. Look at the hierarchy. Compared to plus and star, star has the highest priority. After star, only plus comes. Okay. So the multiplication will be performed first, and the associativity is left to right. If you see, it will scan from left to right. Okay, this is the expression left to right. Uh, star is star is having highest priority, so this will be evaluated first. B into C. So 2 into 3, 6. Now A plus 6, 1 plus 6, 7. So in this way, it will evaluate. The next example, within brackets, A plus B star C. You see here, brackets is having highest priority when compared to star. So this will be, the expression within the brackets will be executed first. A plus B, 1 plus 2, so 3. Then 3 into C3, 3 into 3, 9. Other example, A plus B star C division. So parenthesis has the highest priority. This will be executed first. A plus B, 1 plus 2, 3. Then from left to right, star will be executed first, because star and divide, multiplication and division both have the same hierarchy. Okay. And from left to right, star comes first. So multiplication comes first. It will go for the multiplication operation. So already this would have been evaluated. 1 plus 2, 3. So 3 into 3, 9. 9 divided by 3. So answer is 3. Okay. Then B is equal to A plus B star plus C. The three operators are available in this expression: plus, star, and plus plus. Okay. So among these three, the plus plus has the highest priority, as you can see here. From the top, you can see plus plus is the unary operator, increment operator, has the highest priority when compared to star and plus. So plus plus has the first priority, and star second priority, plus third priority. So this will be executed first. So C is 3, plus plus 3 is 4, then 4 into B2, 8, 4 into 8, 4 into 2, 8, 8 plus A1, 8 plus 1, 9. Fine. Hope you understood. Then one more example, A plus B within bracket star within bracket C divided by A. So parenthesis has the highest priority, associativity is left to right. So first parenthesis, A plus B, 1 plus 2, 3. Then next parenthesis, 3 by 1. So here 3, here also 3, then multiplication symbol. So 3 into 3, 9. So in this way, so in this order, in this hierarchy and this associativity, this will evaluate the given expression. Then coming to the input outputs, you will see how to get input from the user, and similarly how to display the output on the screen. For that, we can use the instructions or statements or functions scanf and printf. Okay, so the syntax of the scanf function is within brackets scanf, within brackets two arguments are there. First argument is format specifier, second one is address of variables. Okay, format specifier means in which format the input has to be obtained. So these are all the format specifiers. Format specifier is one which follows the percentage symbol. So percentage C, percentage I, percentage G, and similarly percentage F, and so on. So depending upon the type of input we are going to get, we can use the respective format specifier. Okay. So if you want to get the character input, we have to use the format specifier as percentage C. If you want to use the decimal integer, we have to use either percentage I or percentage G. Octal number if you want to obtain, then percentage O, and so on. Floating point F, like that. And the second argument is the address of variables. Here we have to provide the address of the variable. Okay. So for this, normally we will be using the ampersand symbol. So the ampersand symbol will get you the, already we have seen the miscellaneous operators. Ampersand variable will get you the address of the variable. Because when we declare the variables in the C language, what will happen, for every variable, unique address would be assigned in the memory. Okay. So to get the memory address of the variable, we can use the symbol ampersand that we can see in the example. And coming to the printf statement, that is, this is used to display the information on the console or visual display unit, that is standard output device. Standard input device is also console, that is visual display unit. Okay, the same format, but only difference is instead of address of variables, only variables are there in the second argument. Okay, here again the same format specifiers can be used, that is in which format the output is going to be. Okay, so input can be obtained using scanf, output can be displayed using printf statement, and these two are the inbuilt functions in the C language. Those two functions are available in the header file stdio, that is standard input output header file. So this header file has to be included to make use of these two functions. So normally this header file is included in all the C programs because we will be frequently using scanf and printf statements. Fine. And some other examples. For the scanf, you see here scanf within quotes %d, comma ampersand. So %d means what? %d means decimal number, decimal integer number. So I want to get a decimal integer input from the console. That's why I have given %d, comma ampersand. So n is the name of the variable. If you affix the ampersand symbol in front of the variable, it will get you the address. Okay, that is the syntax of the scanf statement, right? So now we can get the integer, decimal integer value. That's the first name. Here two variables are there. So to use this function, we should have declared the variable I as integer and j as floating point. Okay, because the first format specifier %d is meant for I and second one is meant for j. So I can get what? A decimal integer value in I and floating point value in j variable, because %f is meant for floating point, right? Decimal integer for I, floating point for j, and scanf f. So we are getting a floating point data in the variable, right? So here that means what? When we use %f here, already this variable should have been declared as a floating point variable. Here n variable n should have been declared as integer variable. Fine. Here LF stands for long float. Long float. Suppose if you have declared the variable n as the data type double, then we have to use LF, long float. Right. Then if you want to get a character, single character from the console, first this. So if you want to get the group of characters or string from the console, then you have to go for either %s directly, that is s for string, or we can have the number of characters, that is width of the string, as you can see here. So here I have declared the variable name as an array variable of type character. So name of character, name of file means what? The variable name will be declared as an array variable of type character, so which is having 5 characters. So here the array variable itself will be acting as a pointer. Pointer means it will provide the address automatically, so that we should not give ampersand symbol. That is the important point we have to note. So scanf %s, comma ampersand name we should not give. We should give only name. So here the variable name itself is a pointer variable. This will provide the address of this array. That means address of the data name of 0. Because when we declare a name of 5, what will happen? It will allocate 5 memory locations in the memory right from name of 0 to name of 4. So we should not give ampersand here. Here also I have specified what? %5c. So it's a group of characters. String. Here also we should not give the ampersand. Automatically the address will be provided in both these cases. That is a point to be noted. Alright. Similarly, we can try for the other format specifier. Coming to the printf statement, see some other examples. Some constants are assigned here for character, string, float, integer, double, etc. And I am using some of the format specifiers. So printf character is percentage C. See here, you see here I have not given the ampersand symbol. For the printf, we should give only the variable name. Right. In C already I have stored A. So this will print whatever given within the brackets, that is character is will be displayed, and this is the format specifier. So a character has to be printed, which is available in the given variable. In this variable A is available, so it will print A. In string I have stored GC Srirangam. So string is, in place of percentage S, what will be printed? The string constant stored in the string variable str will be printed here. That is why I am getting string is GC Srirangam. Similarly for other things, okay, floating point, then integer value I am printing. Percentage D will print the integer value, that is decimal integer. If you want to display the decimal value in octal form, you can directly use percentage O. And the same variable number I have stored 150, but the format specifier is given as octal. So this value will be automatically converted into octal form, as you can see here. 226 is the octal equivalent for the decimal integer 150. Similarly, hexadecimal. Percentage X will provide you hexadecimal equivalent. And here I have used something different. That is, I am specifying the width also. Okay, percentage 4D and percentage 4O. First format specifier is meant for first NO, second is meant for second NO. That is a variable number. Okay. Previously, percentage D was used. Now I have used percentage 4D. That means this is the formatted output. I want to get the formatted output. So the value in the number should be printed or displayed in 4-digit decimal integer form. As you can see here, the space is there because for the numeric values, the justification is right justification. Okay. For the characters or the string, it will be left justified. So here it is value, numeric value. So right justification is followed. That is why the value number is displayed in 4-digit form. First space, then 150. And second one, octal form, same number. That is also displayed in the 4-digit form. That is why a space is there. So this can be used for the formatted output. We can specify the width, that is formatted output. And for double, we can use long float, as I already told you. Okay. Hope you understood the various operators available and the functions of those things, and how to handle the input output in the C language. Thank you.